Well, hello everyone. This is Sunshine from SheNodes, and this is an introduction to the Ethereum Rocketpool node setup. Now, this guide is designed for those with little to no technical experience, offering a user-friendly pathway to becoming an Ethereum node validator through the Rocketpool protocol. The Rocketpool documents manual should be used along with this guide. This is not to be used in replacement of the Rocketpool guide, but an additional layer of breakdown for the non-tech individual. If you've ever been intrigued by Ethereum's potential but felt overwhelmed by its technical complexities, fear not. This guide simplifies the process, breaking down intricate concepts into manageable steps. By the end of your journey, you'll not only have a fully operational node, but also a deep understanding of the role of the network security and the opportunity to earn rewards. No technical background is required. We'll guide you through every step. Let's get started. This video is one of a 4-part series, each broken up into bite-sized pieces for you to better understand and keep your attention. In today's video, we will unbox the hardware, install the software, and gain access to SSH. This guide gives no financial advice, but an educational initiative only. Today's video is setting up a node within the Rocketpool mini-pool protocol on the Ethereum network. Let's review these steps. Number 1, purchase and prepare your equipment. Number 2, install the RAM and SSD. 3, flash the Linux software on the USB. 4, transfer the software to the NUC. 5, set up the software on the NUC. And 6, use SSH for remote access. Let's go over some quick tips to help you be successful and save time. Here are some resources for you to use. Follow along the Rocketpool documents with this video. Other resources, eStaker website is a great option to read prior to getting started. Of course, there's Reddit, GitHub, YouTube, and Phone a Friend. I will caution you on using ChatGPT. This is affording hackers from all over the globe. Bad actors may be able to trick the AI into generating or hacking the code. And of course, there's the potential for ChatGPT itself to be hacked, so be safe. The most important resource is the Rocketpool Discord. Use the Rocketpool Discord support if you are halted in a step or getting errors. Help from the team will definitely save you time, and they are so very helpful. Read through the documents and the responsibilities on the website. Here's the location of the guides and Discord. Ethereum Launchpad will also give you an outline of expectations, but not required. You will be doing everything through the Rocketpool protocol. Last, take your time. Consider breaking the steps into days if you need to. Before getting started, you will need to select your hardware and choose an operating system. There are several options for hardware, so select one that works best for you depending on your price range and your experience. There will be some manual steps with Linux support, which will be required. Refer to the Rocketpool manual and follow along with the guide. Here are the minimum requirements. OS Linux or Mac OS. You'll need a quad CPU, 16 gigabytes of RAM, and a minimum of 2 terabytes of SSD disk space. Now, SSD is not a place to skimp. Please get NME or non-volatile memory express and avoid QLC. NME is more efficient and enables faster data transfer between storage devices and the rest of the system. For more hardware information, you can check out the GitHub post below with Yorick Hall of Blame, or you can also go to eStaker, who also has great hardware examples. Okay, so here's the hardware that I have chosen. The NUC 11 bare bones, the Vengeance 32 gigabytes of RAM, the Samsung 2 terabytes of SSD. You will also need a USB to flash the drive, and later you'll need a hardware wallet, which I am using my Ledger. I will be using the MacBook Air for SSH, and I will also use a monitor and keyboard to connect to my NUC for setup. RP has specific guides for setting up a NUC that you can refer to. Your next step will be to install the SSD and RAM into the NUC. This step took me about 10 minutes. Here's all the equipment that I purchased, and you'll need a Phillips head screwdriver to access inside. It does not take much effort to remove the back panel. And once you have it open, there is a small screw that needs to be removed for the SSD card. It's very tiny, so I used tweezers for better dexterity. Next, snap in the RAM, and there you go. She is all ready to go. You are now ready for the software installation. The next step will be to download Balena Etcher and download Ubuntu. The site is listed in the Rocketpool manual. You will flash with Balena Etcher and load it on the USB drive. Now, Linux software desktop options include Ubuntu, Debian, CentOS, and Fedora. For this setup, Ubuntu will be used. You will need to download Balena Etcher. Balena Etcher is a tool designed for creating bootable USB drives for flashing operating system images on removable storage devices. Here are the websites for the download. Okay, you should have your USB connected and ready to go. To flash the drive, you're going to select Ubuntu, and then you're going to want to select the target, which will be the flash drive or the USB. Next, you can choose flash, and you're ready. You flash the drive. Now, if you run into difficulty doing this, I found it was related to my Mac security settings on the USB. You can go under the hardware selection and select USB to see if your Mac recognizes any connected USB devices. If the ports are functioning correctly, you should see the connected devices that are listed. In this process, we will install Linux and set up your password and network. Make sure to write everything down. Linux is an open source operating system that uses command line interface that is used to execute commands. You are now ready to take your flash drive and transfer it to your NUC for the Ubuntu install. Now, I connected a monitor and keyboard for access. There are great directions online. I will not go through this entire process in detail because it is pretty straightforward. When you plug in your live Ubuntu USB drive into the NUC, have your system boot from the USB disk instead of the hard disk. You can do that by moving the USB up in the boot order. Restart your system, and when you see a logo on your computer manufacturer, you can press F2 or F10 or F12. One of those will work, and then you'll have access to the BIOS settings. Again, these are straightforward directions. The most important thing is that you make sure that you copy down the computer name, IP address, username, and password that you have created. Make sure to keep them in a secure place and do not share this information. You'll need to type the secure key or the password every time you boot Ubuntu, and also to mount Ubuntu from another machine or system. They need this key as well. There's an easy wizard system that will prompt to set your account up, computer name, IP address, and location. Again, make sure you write down that node IP address so you can access it later. You will need to install Sudo. This allows permitted users to execute a command as a super user. You also may hear this as a root. You can follow the command line in the guide. In this step, we will install SSH on your client machine. SSH stands for Secure Shell, and it's used to provide a secure way to access and manage the network devices remotely using CLI, or command line interface, which means interactions are done entirely by typing commands into a command line terminal. Again, in this guide, we will use the MacBook Air laptop via SSH to communicate with the Intel NUC processor. This works by using an accessible server used on a public IP address. The username and password on the server that was created in Ubuntu will be used. Follow along here on the directions below. Now make sure that remote login is allowed by the administrator. You can pull down the Apple logo menu and go to System Settings, open the General Preference panel, and then go to General and toggle to Remote Login. And remote login to turn on the SSH server. The SSH server will start immediately, and then Mac is able to receive inbound SSH connections. You can then access the terminal for the rest of this video. Now you will connect to your node by using your username and IP address of the NUC 11 node. The first time you connect to the server, you'll be asked to verify the public key of the server. And then on future connections, the client will reference the verified public key to ensure that you're still connecting to the same server by referencing a known host file. After SSH is enabled, you now have access to execute commands on your server remotely. Your next step will be to set up swap space. Steps will be to create a swap file and then configure the swappiness and cache pressure. Swap space is a part of the hard drive that can be used as virtual memory when the physical RAM is fully utilized. The SSD will be utilized as a backup RAM. Now, it helps prevent the system from running out of memory, and it allows it to continue to operate by moving less frequently used data from RAM to the disk. Now, let's make a new file that will act as your swap space. Decide how much you want to use, and for my case, I will use 16 gigabytes of swap space for a total of use of RAM for 24 gigabytes. But you can just substitute whatever number you want. Follow the commands to make the changes. Last, you want to verify your changes. Run the command to show your output. You should see a screen like this below. I have it enlarged, paying attention to the circle. If the second number in the last row labeled swap, the one after the line there, is non-zero, then you're all set. For example, if it shows 0/24 in the last row, your swap space was activated successfully. Last, configure the swappiness and the cache pressure. Cache memory is small and fast temporary storage area on the CPU for easy instant data retrieval. It really acts as a buffer between the CPU and the main RAM. Adjusting the swappiness determines its willingness to utilize the swap space. So adjusting swappiness is relevant in situations where you want to influence the balance between keeping the data in the RAM for faster access and utilizing swap space to free up physical memory. This will really optimize your system's performance, and that's why we are doing it. Follow the command line by putting this in the system config file so that they are reapplied and after reboot. Save and exit, and you are finished. You have now completed all 3 steps of this video: unboxing and hardware, installed the software, SSH remote access, and the swap space. You are now ready to move on to video 2, where we will secure your node and install Rocketpool. Congratulations on your accomplishments. We will see you in the next video.